Perfect.
Thank you so much, Louise. And hello, everyone, and welcome to OTS Connects. Thank you so much for giving of your own time to join us tonight. We are this year very fortunate to have received funding from the ministry to support teachers in gaining skills for instruction in mathematics. So because of this, we're able to offer a lot more math sessions and also in the area of technology. It's my pleasure tonight to welcome Mary Kate Goindy, who will be facilitating tonight's webinar on developing number sense through math problem solving. Mary Kay has facilitated a number of OTS Connect sessions over the last 3 years, and as Louise mentioned earlier, she also did the 3-day Summer Institute for OTS this past summer. She certainly brings a lot of experience to share with us tonight. So Mary Kay, welcome, and I'll pass the mic over to you.
Great, thank you. How's the volume? Could you give me thumbs up if I'm coming through okay? I was heavy breathing because my mic was a little too close to my mouth before. Okay, seems to be okay. I don't see a lot of thumbs up or anything like that. Great, perfect. Welcome, recording's going. I guess I'll just go on. Nice sale price, if you notice that. Not? No LOLs? Okay, good. LOL in the text. I can see that. Thanks. And this is not me, but it is me. So I just wanted to apologize first if my voice croaks out or I head into a coughing fit. I'll turn my mic off as fast as I can, and I promise I'll be back. I've just been battling some, well, I've just started teaching in kindergarten, so I have got everything going. So any cold, it's now mine, and I am proudly owning it. So there are 3 kinds of people in this world: those who are good at math and those that aren't. And yeah, right, Gianni, sorry, I'm like a squirrel. Yay, sharing. This basically summarizes our society right now. We've got a math-phobic society for the most part. You know, some people love math, but those that don't love it really are afraid of it. So in terms of that, just take a second. And basically what I hear some teachers saying is that they're scared to try something new in terms of how they teach math. But I think if we don't try something new, we're just going to create another wave of this math-phobic society. So it's really time for us to start looking at things differently. And I think this whole teaching through problem solving is the way to go. And I've been teaching this way for about, well, I'd say the last 10 years for sure, and I would never even consider going anywhere close to what I used to do before. I guess I should give you a bit of a background for me. I teach in Upper Grand District School Board. I have taught for 23 years now. I did 4 years as the math curriculum leader for our board, and I've last year returned to a classroom, grade 7 and 8 classroom. And this year, second week of September, our school was reorganized, and I became the proud new FDK teacher down the hall. So that's my experience, and that's what I'm bringing to this conversation. I really don't want to be the only one talking all night, so jump in, grab the mic. I hope to really reinforce or encourage you that what you are doing is right and you're on the right track. And I also hope to share a few new ideas to you or for you and maybe challenge some of your current beliefs. So cookies, everything, see, this is my FDK coming out. Everything comes back to cookies. And this is about, this is from a monograph that the ministry put out a few years ago. Something about following rules. And I can't remember the title of the monograph. I think the link to the monograph is going to come into the chat window. Maybe Louise could pick it up from my speaker notes. But it talks about some research by a man named Paul Cobb. And what this man did was he was interviewing grade 2 students. And he was meeting, and I can't remember the number in the study, it's in the monograph. I'm not a details person, sorry. But he was interviewing these students, and he was asking them if they would have a strategy to add 16 plus 9. And in his interviews, 100% of the grade 2 students told him that 16 plus 9 equaled 25, and they went on to describe to him a variety of different strategies that they used to come up with this answer. So he was thrilled. A couple weeks later, he comes back into the same group of students, and he provides them with the traditional addition problem written vertically. So 16 down below plus 9, and ask them. And less than half of the students got it right. The same math question that they had correctly done 2 weeks before, they did not get it right this time. Can anybody predict, maybe in the chat, 16 plus 9, what were their wrong answers? If they were no longer answering 25, what were they now answering? Any predictions? (16 plus 9). What do you think their wrong answers were? 106. Okay. 15. Anybody else? 169? 115. So I've seen the two most popular wrong answers. 16 plus 9, the same students who 2 weeks before said it was 25, most of them were saying it was either 15 or 115. Anybody want to jump in why? What was their issue? Absolutely, regrouping. They didn't know what to do with that carrying of the 1 kind of thing. And here's what struck me most, and this is the part of the quote from the whole monograph that I remember, is he interviewed these children and talked about why these answers were different. And one little girl told him, he said, well, if I was in my mom's kitchen and we were adding cookies, 16 plus 9 would be 25 cookies. But at school, it will always be 115. And that just shocked me, that she would see she has abandoned what she knows for some reliance on executing these math procedures. And the quote from the monograph, I'll just read it, says, most children will, with extensive practice, eventually learn to use traditional algorithms with some competence. So we could spend time and teach the traditional algorithm and get most students to be relatively successful. But the quote goes on to say, this skill often comes at too great a price. Students learn to ignore their own reasoning in favor of following rules. And it's this, their own reasoning, that is number sense. That's just a way to be numerate. And that's just making sense of the world of numbers that surrounds us all the time. And that's what I think we really have to work to build with our students. Take a second to read this. And I think we all have seen students, and maybe we were those students, that we learned how to get the right answer, but we didn't know why it was the right answer. We didn't even really care that we didn't know why it was the right answer. We just were motivated to keep getting right answers. And that kind of education is not going to serve these children well. I think it was okay for us, but it's not going to lead students into their future very well at all. Another, this reminds me of a blog post written by a man you might know of, Grant Wiggins, and he's an American and he does a lot in educational research. He with McTeague wrote Understanding by Design. Maybe you know that. But he has a blog, and I can find the link to that blog. I read it quite often. But he was talking about his work as a soccer coach. And he was realizing the huge connections between his work as a soccer coach and his work as an educator. And what he said was, quoting him in the blog, it said, "My greatest learning as a teacher came on the soccer field. We had been working for a few weeks on the same key moves on the field relating to creating space. After a few practices, the team looked good in the drills, and he thought to himself, they've got it. Then the next 2 games, nothing. Nothing like he'd seen in practice. And finally, being super frustrated, he yelled out to the captain, 'Do what we do in the drills.' And the girl yelled back to him, 'We're trying, but they're not lining up in the proper way.'" And that, to me, spoke of things that I've done in class where I think students have got it, they've got it, and then I give them a chance to apply it, and it falls flat. Anybody else have that experience? You think you've taught it so well, and then when it comes time to apply it, it gets lost. And this was in a blog post that Wiggins was talking about some of his new ideas, and it has to do with transfer. And he goes on, oh, well, I'll just let you read it. I don't need to read this to you. This whole leading students towards scripted behavior, I would say that was my goal. I maybe wouldn't have articulated as being that, but that would have been my goal maybe 10 or 15 years ago in my teaching practice. I wanted everything to look the same. I wanted students to know how to start at the top of the page and work towards the bottom. I just wanted everything to be quite formulaic, lots of prescribed organizers or ways to answer questions. And I realized how I was doing a disservice to the students. So teaching through problem solving, I see as being the second quote there. That whole transfer comes in where students feel empowered and are able to persevere. They have resilience to go through and keep looking for connections and moving forward. And so that is the kind of learning that I want for my students now. It's the kind of learning, too, that EQAO expects. When they define mathematical proficiency, they are not just looking for the scripted answers to calculations or the very scripted answers to word problems. They have 5 aspects that they look for, and the first is procedural fluency. Well, first I say because it's first in the list, not because it's the most important. Then conceptual understanding, then strategic competence, adaptive reasoning, and productive disposition. And that, I had students before, procedural fluency, out the yin. They were good at that. Conceptual understanding, maybe not. Strategic competence, did they know which strategy to choose when they were presented with a problem? Less likely. Adaptive reasoning, that's the big one, right? Where you know something and you can kind of just tweak it a little bit so it works in a new situation. And then productive disposition. This goes back to the very first quote about the 3 types of people in this world. Productive disposition is that thinking that I can do this. I can solve this problem. I can figure out this math question. I can make sense of my shopping budget, all that sort of thing. So productive disposition, definitely a goal. I was definitely in this trap before, where I thought it was about my teaching. I thought I had to make it clear to students. And now, funny enough, I think it's exact opposite. I see my job as to make it muddy for students. Sorry, Laura, you think that students expect the lockstep straightforward? Yeah, for sure they do, because that's easy, right? For our high-performing students or our traditionally high-achieving students, that was the route to the goal that they wanted. Their goal is a high mark. Probably not for all our students, and I think that as I've changed and taught through problem solving more and more and more, I start to see my class very differently. I start to see kids that would have maybe traditionally been described as not successful in math as my strongest math students. So it's quite interesting. So it's this whole thing about making experiences in your classroom ambiguous and make them cloudy so that students have to struggle. Because for all learning to happen, there has to be cognitive dissonance or that mental struggle. If there's no mental struggle, they're not learning, they're practicing what they already know. And not that practicing is bad. Practicing is really important, but it's not necessarily learning. So, time for me to talk less and for you to talk more. I notice nobody's grabbing a mic. Did anybody want to say anything so far? These are just some background ideas as to why I'm so motivated to teach through problem solving. Okay, so I'm hoping Louise can help. I'd like to go off to a whiteboard. And I have never done
I've got my mic on
a whiteboard before.
So we are all good. So the slide is the whiteboard, so you just need to let them know whether you'd like them to grab a text tool or a drawing tool from their tool strip at the left.
Excellent, thank you. So I guess you're going to need a text tool then. And my question is, think of a time that you were faced with a problem and what comes to mind. So anything that comes to mind, picture a problem you've had, not necessarily a math problem. You don't have to tell us your problems, but just think about things that come to mind when you were dealing with that problem. And I did see a comment in the chat about special needs. I will get back to that as soon as it's done. So just cover this whiteboard with things that came to mind. And I'm just going to turn my mic off before this coughing fit hits. You can keep talking about things that come to mind when you're dealing with problems. Okay, I see the adding to the board is slowing down. So just take a second to read what other participants have added to the board, and maybe you might comment, or that's going to spur on another idea for you. So I don't see a lot of positive words. I don't see, yay, another problem I have to face, or anything like this. And that's exactly what I was expecting. Did anybody want to comment to some of these ideas in the chat or grab a mic? Ooh, a puzzle there. I see a positive. And not that the others are negative, but it's just whenever we're faced with a problem, there's some anxiety that comes with the whole notion of a problem. Oh, fixed mindset. Excellent. So I hope, Sandra, that means you want going to more to a growth mindset. So, absolutely. Going on, and I'm just going to leave this slide, and we'll come back to some of these ideas in a second, or not a second, but a while. Classroom culture. If you are going to pose problems to your students, real problems, not word problems, not problems that they know the answer to, it's just a word story, what is your classroom culture going to have to be like for students to deal with problems in your classroom? Again, I think this is a whiteboard. Louise will correct me if I'm wrong, so please add your ideas. If you are going to pose real problems to students, what should you consider about your classroom culture even before you do that? Anybody want to put some ideas down about how we create a safe environment? How we make it respectful? Anything that you do? Restorative circles. I'm not familiar with that. Thanks for the link there for restorative circles and for the discussion, or for the description there. I got to look into that for sure. Natural curiosity. That's on my bedside table. I know I need to get into that a lot more. Please tell me I'm not the only teacher nerd with professional reading on her bedside table. So you guys obviously have all kinds of ideas, and I would say that before you even worry about the math, it's this that you have to do. Anything else that you do before this is in place, I think is possibly wasted classroom time. Anybody still adding ideas? I haven't seen anybody flash one up in a bit. So going on. And I think this is a time for Louise to show her to help us with the video, put the link up. This is Jo Bowler, and she has been working with the Ministry of Education in Ontario around the idea of math instruction. She also works a lot with Carol Dweck, who somebody already referred to fixed and growth mindsets, but that is the work of Carol Dweck, that whole psychology of mindset. And these little video clips, if you haven't found them, are shared on curriculum.org, and there's a link at the end of this slideshow for you to get more of them. This is just one of the brief clips, and really only the first half of this clip relates to what we're talking about right now. But I think the second part of the clip is equally valuable in other contexts, and since the clip is only 4 minutes, I thought maybe it would be good to watch it now. So,
okay, this is where I'll jump in. I'm going to switch our whiteboard into web tour mode. I'm going to put a link in there, and your whiteboard should turn into a web browser with the video. If the video doesn't start automatically right away, you can click right in your screen and click on the play controls. Any trouble there, the link is now also in the chat.
Thanks, Louise.
Give us a green check mark when you're done. Okay, sorry, I'm just going to jump on. If you're having trouble with the video, just click on the link in the chat.
See lots of people finishing up. Is green check mark the best way to show so we know everybody? And Louise, I'm thinking that you navigate us away from this page, but if I'm wrong, oh, there we go. Thanks. Just scrolling up to Sandra, that is an awesome quote. Out of the mouth of babes. Effective teachers know that a wrong answer, well, you can read it, but I think effective teachers also know that a right answer doesn't necessarily mean understanding. It could just be a fluke. It could be the right answer via wrong thinking or faulty thinking, or it could be just that rote execution of the algorithm with no understanding. I agree, Sandra. Very compelling message. I love the line in the video where she said, to maximize learning, put kids in our classrooms and have them struggle. I mean, that's exactly what I thought I wasn't supposed to do a long time ago. And she does go on to say support these kids that are struggling, and I think the three-part lesson that we'll talk about in just a minute is exactly that kind of support. But it's this unexpected thinking, I think, that refers or relates to that whole number sense that we want to build with our students. And so this book, I hope it's not a new book for you to look at, very familiar. probably almost out of date now, 2005, but that's our math curriculum in Ontario. And I actually think it's a pretty fabulous curriculum, to be honest. Lots of great things in it. And while I won't give you time necessarily right now, but page 24 and 25 in the front matter, and if you haven't read all the front matter, it's good professional reading. But page 24 and 25 specifically are the call for us to teach through problem solving. So really, it's not even an option for us. I mean, we're supposed to teach our curriculum, and our curriculum has demanded a teaching approach of teaching through problem solving. The problem is I think that when people hear problem solving, because of how we were taught, or sorry, how I was taught and how lots of teachers were taught, we maybe wrongly first assume that problem solving and word problems are the same. And while they might be, there are lots of word problems that students complete that have no problem solving component to them at all, because the student is not struggling. I think back to the textbook pages that I used to complete as students, where at the top of the page they show you an example of the calculation, and then let's say you practice it by doing 10 addition questions, just the raw calculations, and then at the bottom of the page there were maybe 2 or 3 addition word problems. And really you didn't even have to read the problem to get the answer, right? Because you just grabbed all the numbers out of the problem and actually added, because that's what you'd been doing for the top part of the page. And then you only really skimmed the question to know what you should put in that therefore statement that you had to end your calculation with to get full marks. So I think a lot of us maybe were a little bit slow on the problem solving shift, because we were equating problem solving with word problems. And while they might be the same, they definitely might not be. My other favorite part of the curriculum are these math processes. And when I was looking at these, the only 2 that I don't see directly linked to problem solving or solving problems or struggling are the whole communicating and representing. But the whole selecting tools and knowing which strategy to use and reflecting on whether or not you were on the right track or does your answer make sense, and this whole connecting that adaptive reasoning to know you did something yesterday or last month or last year that might apply now, and the whole reasoning improving. And I think somebody talked about that, just Jenny said that's why it's important to show your thinking, and that's the whole reasoning and proving part for sure. So thumbs up, or I guess, yeah, I think there's a thumbs up in the thing if you're quite comfortable with the math processes and integrating them into your program. Oh, I only saw 1 thumbs up. I hope I was just too slow to scroll. Ah, there we go. Is that Jacqueline Calder doing that? Excellent. That would be a great session. So here's, hopefully looks very familiar to you. Just grabbed the grade 4 because when I scrolled through the participants, it was all grade ranges across the elementary, so I hit the middle. Just looking at number sense enumeration, these are the overall expectations, and there are 4 of them in grade 4. And this was new learning to me. The quantity-specific expectations are the first overall expectation, and I'm just wishing that the headings that I've put in here in red were actually in the original curriculum document. But if you've got your curriculum handy, do you see how the overalls link down to the specifics? And really there's only the 4 overall expectations that we're responsible for evaluating and commenting on. And grade 4, teachers for grade 4 and 5 actually, if you feel that you do more work than the rest of us, you're right, because every other grade only has 3 of these expectations, overall expectations, but grade 4 and 5 have all 4. And so if there's a document I created, which is just almost a scope and sequence of all the overall expectations. And I think there's a link going to come up in the chat, which will take you to that page. Sorry, off topic here. I'll absolutely repeat it. Problem solving is not necessarily word problems, because a student could solve a word problem correctly if it follows, if they already knew what operation to choose, they would just be executing the calculation required. So if we have been doing adding all day, and I present my class with a word problem that includes adding, it's not really a problem for them to solve. It's just going to be a story version of the adding algorithms. As opposed to problem solving, which is they even have to choose which strategy, which operation, which numbers to pull in. Everything would be up to them to make decisions and assumptions and kind of navigate. Awesome. No problem, Corinne. So, Louise put a link there to that file that I created, which outlines all of the overall expectations. And I just thought I'd give you a couple minutes to look over that. And then I was going to think, I didn't picture how a whiteboard works quite properly, so I didn't put in a blank screen, but I guess we could write right over this screen. And just, what do you notice and what do you wonder about?
I've got one ready for you, Mary Kay. So
you are awesome. Thanks.
Here. And in about 2 seconds, we're going to have that's a very crooked line. That's not going to do.
It was straight.
Okay, we're going to do the 2 columns. So Mary Kay, you can describe the activity while I get the text up here, and we'll be good to go.
Awesome. So take a second to open up the document, go to your grade, and start looking at your grade, and then the grade above and the grade below. Or maybe pick one of the overall expectations and go through all of the grades and just see how the expectation changes across the grades. And then come back to the whiteboard, and there's a side for I notice, and then there's going to be a side for I wonder. And just record some of your thoughts or some of your noticing in terms of the overall expectations. And as it says at the bottom, all the emphasis is added by me. That's not in the curriculum document, but I put a few things in bold and a few things in italics because that was helpful to me. Laura, did you get that question now? I think my cough candies are starting to make my head go a bit loopy, so. Hi, Almas. If you go back and scroll up in chat, Louise shared a link to a Dropbox file that I created. And people are just taking a second to look over. It outlines the overall expectations across the grades. And then just come back to this whiteboard. Anything that you're noticing or anything that you're wondering about the number sense and numeration overall expectations. Just jot down a couple ideas here on the whiteboard. No problem. I just should invite you to add comments to other people's noticings and other people's wondering. If you can jump in and answer, it'd be great. Okay, I think your slowing typing and my coughing fit are coinciding, although people are still going on. Fractional relationships, I see the first, I wonder. Definitely in the FDK program about composing and decomposing, and we go down to halves and things like that. Now, in terms of being numerically represented, fractions aren't numerically represented until grade 4. So the word half and third and quarter get used in grade 3, but the 1/2 arises in grade 4. Fractions then come back in grade 4 and 5 once the proportional relationship strand kicks in, because, not strand, sorry, overall expectation, because we start to see the relationship between fractional parts and percents and rates and ratios and everything like that. The comment about why meaningful contexts are mentioned in grade 8, that is a great question. I've often had conversations about that. I think it's a huge oversight. Should be everywhere all the time. That should really just be on the front of the curriculum document in meaningful contexts. How do we work to fill gaps from previous years? I noticed somebody said the expectations build from grade to grade, and somebody also had at one point that the numbers get larger every grade. But interesting enough, the numbers never get smaller. So there's no minimum. It's not like grade 8s can't solve problems with 2-digit numbers. So if that's a gap that exists, I often let students go back to where they have their number sense or where they are comfortable calculating. Are they going to get a level 4? Not likely, but that's not really my goal for that student. My goal is for them to increase their number sense. So whether that means a good mark on the report card or not is not really concerning to me. I just want them to move forward. So oftentimes what I do to fill the gap is I will give a word problem with a blank and let students fill in their own number. And that way I know that I can see their understanding of maybe division or equal parts or that proportionality and see what they know and not just see what they can't do because the numbers don't work for them. Lots of my students often choose to work in whole numbers and not decimals. That shows me, one, they're not comfortable with decimals and I need to support them, but it doesn't get in their way of they're showing me their understanding for the other aspects of the math curriculum because it's so rich and there's so much there. I see somebody mention Enrich. If you haven't used that, definitely a good source of problems, or NCTM. I think for time, unless somebody wants to jump in and make a comment with a microphone or in the chat box, I'm going to move on. I hope that that document actually helps you see. It's always reassuring to me because when I'm teaching my grade 7s last year, I don't have to start again. I know where they probably ended in grade 6, and then I just have to move them that little bit more of sophistication or into the next number, magnitude of 10. Actually, I do want to go back because a lot of times the Number Sense curriculum, I'm just going to find one exactly. If I look in, well, let's just say it says solve problems, grade 5. Solve problems involving multiplication and division of multi-digit whole numbers. Here's my question. To meet that overall expectation, and I'll read it one more time, solve problems involving the multiplication and division of multi-digit whole numbers. Does a student actually have to multiply or divide to meet that expectation? That's my question for you. If the expectation is solve problems involving multiplication and division of multi-digit whole numbers, does a student actually need to multiply or divide to meet that expectation? See Lindsay's answer in the chat box. Dawn too. You think like I think, and some people will argue with me, but the expectation is that they solve the problem. It doesn't say they must use multiplication or division. So I see that as my teacher responsibility is to provide a multiplication or division problem. The student's responsibility is to actually solve the problem. And any strategy that they can do is fine with me, as long as they're solving that problem. So now part of it talked about going into the, and I know you all want problems, and I'll get there in a sec. Minds-on, action, and consolidation. How many of you are familiar with this basic structure? You may be numbered or name the parts differently, but this is the three-part math lesson that has been how we're teaching math in Ontario, or how the ministry would like us to. Benita knows it. Karen knows it. Good. I'm going to assume most are familiar with this basic three-part lesson. So I see it as being a 1 to 3 to 6. So one of all the time you have for your math lesson, and not every lesson is going to be a three-part math lesson, but if you're doing a three-part math lesson, you divide your time into 10, and one of those parts is for your minds-on. And 3 of those parts is for your action, and 6 of those parts is for your consolidation. So last year in my grade 7-8 class, my minds-on would have been 5 minutes because I had a 50-minute class, and my action was 15 and never more, and my consolidation then, I had the last 30 minutes of class for consolidation. Now the periods are the same length, but now that I'm teaching FDK, my minds-on is 1 minute, my action is 3, and my consolidation is 6 minutes long. And I just do 3 math problems in a day following this format, as opposed to 1 50-minute class. The grade 1 and 2 teachers in my school basically do 20 minutes math problems, so they follow the 2, 6, 12. And this is just how we're making sense of this. There's a link coming up, I believe, about the minds-on. So minds-on, the purpose of minds-on, or maybe it's called getting ready or whatever, but you are warming up or priming the student's mind to be successful in the action that's coming, because you're going to provide them with a problem or, you know, cause them to struggle, as Joe Bowler said, but we also need to support them. So this minds-on, it's like putting oil in the car before you run the car. It's just getting things geared up. I also would suggest that your minds-on is very closely linked to your learning goal. Not that you would state the learning goal to your students at this point, but it's definitely going to help get you what you want to see this period, so it should be related to your learning goal. Louise put a link to, I can't remember what it's called. It was called Minds-on Support Resource. Yeah. Yeah.
I'm going to repeat that in the link, so it's the soonest one there. Sorry.
Okay, thanks, Louise. This is just another document that I created when I was the math consultant to help people get ideas of what they could possibly do for a minds-on. It might be playing a quick game. It might be just putting up an image and having them notice or wonder something about it. I won't go over the list because I know you can read that on your own time and contact me if you have any questions. My only rule for Minds On for myself was that every student must talk. And since it was only going to be 5 minutes in my grade 8 class and 1 minute in my kindergarten class, that really made it important for me to have elbow partners or turn and talks. So I required every student to talk during a Minds On task. And I found that to make a huge difference in terms of the success and the engagement of all students during the action. So sometimes for the student that really didn't have anything to add, they would ask to speak second in the turn and talk, and they would just paraphrase what the other person had said. So, you know, somebody says their ideas about whatever question I've provoked them with. Student B, who's maybe struggling or not confident, just would paraphrase what student A said back. The words were starting to come, the brain was thinking, they were engaged. You're welcome for that resource, Sandra. Yeah, so going on, that's Minds On. Are there any questions about Minds On? Maybe you'll have questions after you read that sheet, and at the end of the show I'm going to tell you how to get in touch with me anytime if something starts to click or not make sense anymore. So the Minds On, done. The action. This is where the problem lives. So this is where the problem solving lives in your class. Just going to my notes. As I said, a problem doesn't need to be a word problem. This is, in my class, where partners would solve the problem I present. And I'll just say, I never let students choose their own partner for anything academic. They can choose who they sit with on a bus, at lunch, those kinds of things. But for academic purposes, I always have partnered them myself, usually based on the independent practice from the day before. But when students choose partners, there's always somebody left out, and I kind of feel that is almost bullying in a way, and I never wanted that in my class. So I always chose who was going to be partners. So going on to the next slide, not that we're going away from action, turn this into a whiteboard then. So think about what are the qualities of an effective problem for a math class. And I'm going to start, as I see ideas come in, I'm going to provoke and maybe throw a few flies in the ointment as some ideas come up. So just what are qualities of an effective math problem? I know a lot of you have been talking about it in the chat already. Again, I'm going to turn my mic off. That's okay, Dawn. Just keep adding in the chat. I'll just read it out. Dawn's saying that there needs to be a real-life connection and provokes critical thinking. See lots of the same ideas, lots of the ideas I'd agree with. I agree with everything I see on this sheet. Something I don't see yet is the direct link to the curriculum expectation. A lot of times we complain that our math curriculum is so full, but sometimes we do things in our math class that don't relate to the curriculum. So we want to make sure that our problems specifically address one of the specific or overall expectations for sure. Another thing I'd say is that we don't want our problems to be sanitized. Sometimes the teachers do all the work to make it so straightforward. An example would be an EQAO question that our staff was looking at the other day from last year's EQAO. Basically, it was skip counting. It must have been on the grade 3. Skip counting, I believe, by 6s, but it didn't start at 0. It started at 17 or some ugly number like that. And so we have to make sure that when we're giving students problems in our classes, they start at those ugly numbers or the real life situations. Nothing really ever starts at 0 in real life, so we have to make sure that our students get those little, you know, somebody was calling them tricks, but it wasn't a trick question. It was just not so sanitized or cleaned up. Question, effective problem for a math class. Does it have to be a word problem? Do you always give students word problems? I see no. So can somebody maybe give an example of a problem that would be an effective problem for a math class, but not be a word problem, either in the chat or on the whiteboard? See lots of ideas coming through the chat. If you want to direct your eyes that way. Excellent. I love the ideas of having a picture as your provocation for math. I saw the open-ended, how many different ways can you make 37? Something I used to do with my students a lot is you get 15 base 10 pieces and you have to create a number. What number did you create? Is this the only number that could be represented by 15 pieces? That looks like a very merry and small. The answer is 42. What's the question? These are the kinds of things that I think we need to do more of. Yeah, see, I do that. I know that stuff. That's awesome. It's these not necessarily in a word problem, but these are problems for students to solve. What's the benefit of non-word problems in our math classes? Who benefits from non-word problem? Thinking was incredible. Excellent. Benita says it reaches everybody. Absolutely. Absolutely. Doesn't matter where in the unit you might introduce a problem that is a non-word problem. I'm thinking about the achievement chart with the application. Use them as a diagnostic. I agree. I think those kinds of problems are great as diagnostic. Lindsay, can you explain that a little more? Lindsay says it depends on the assessment you're gaining. I think I agree with you. I think the same. Assessment for learning. Yeah, absolutely. So just to give my thoughts on this, early in the unit, I want to give these non-word problems, where I'm really just focusing on the number and the relationships between the numbers. And then as the unit goes on, I see here the strategies. If I'm starting to target the maybe representing strategy, that's going to be a different focus. But then I want to see if they can apply the strategy, and that's maybe when I start to bring in the word problems or have them apply the basic strategies they've been building in real life context. And so I think that definitely matters in a unit when you go. Another thing is this whole real life. We have to remember that it's the real life for the student. And so in terms of primary classrooms, I don't think the problem should be about anything that they can't see at that minute. So my primary classes, lots of problems involving crayons and pencil crayons and glue sticks and scissors and chairs and desks and things like that. Not even cookies and other things that I know they're familiar with, but they can't actually get up and grab it. Because I think for some students, even using the little square tiles to represent cookies, it doesn't work for some of our students. Lots can make that connection, but others can't. And so keeping it real, if you want to do a problem, make it be about 24 pencil crayons, and that's it. They can go and grab the 24 pencil crayons and solve it that way. Seeing the clock, so I'm moving on. How many of you have done incredible equations? I think it's kind of along the idea of the answer is 42. I have done incredible equations. I haven't done them in kindergarten, but every grade I've taught, I did incredible equations every month. And this was a big part of my assessment data in terms of students' general number sense. Not necessarily related to expectations and number sense numeration, but just their number sense and their ability to work with numbers. And so basically, I give them a target, and it was usually the day. So if it was today is what, November 13th, the target would be 13. And they just write down, and I would specify either an expression or an equation. So they got practice with those differences, because those are big differences in grade 9. So we want to start them early. And they just had to write as many as they could, expressions or equations that hit that target number. That was huge assessment for me, because if I had just done multiplication and nobody was bringing in anything multiplication related, I would know that maybe I'd need to go back and do some reteaching. But I could definitely see the skills going across the year. And every month I would just keep that in my journal, in my portfolio, and it was great assessment data for me. Somebody said before, the thinking that came out of the question, the answer is 42. This is the same. You give them a target. The answer is 13. What are the questions? What were the possible questions? Fabulous, fabulous. Thanks, Sandra. Sandra's just pointed us to another. That resource is new to me, so I'm definitely going to check that out. Now, so we've done Minds on Action. The big part of the lesson is the consolidation. And actually the consolidation, the 3-part lesson, is actually 5 parts in my head. But I guess if they called it 5 parts, they were worried we wouldn't do it. But the consolidation, or the final part, I see it broken down as share and compare, highlight, and independent practice. Share and compare is really just this chance for students. And I think I've got it over here. So share is a chance for students to show each other what they have done. So just to go back, my Minds On last year I'll go with was 5 minutes, and my action was 15. At the end of the 15 minutes, I had a visual timer running through the whole action, and when it would go off, it would ding, and they would put their lids on their markers and magnet their work up on the blackboard. I didn't wait for everybody to finish the action. I gave everybody 15 minutes because I think the value is in the struggle and the coming up with a strategy, not on necessarily getting the right answer. Had to build a little bit into my classroom culture to make students okay with putting up work that wasn't done, but that didn't take very long, and we had more time for the consolidation, which is where I think I got my biggest bang for my buck in terms of instructional time. So these are just some strategies for sharing. My favorite one is the last one. So I would have students get up with their work and form an inside-outside circle. And I think there might be a link coming up to inside-outside circle. There's an e-workshop on that cooperative strategy. If you're not familiar with it, you can go to that and check it out. But I'd have 2 circles formed, And so basically, students were talking to another group of students, and their question was often the same. What is the same and what is different about the work that you've just created? Serious students did get frustrated initially, but once they saw the value of the consolidation, they were happy to not have a right answer. They were much more proud of a right strategy and even just an attempt, even if it was a wrong strategy. So the question for the inside-outside circle often, what's the same and what's different about the work that you just created? It got them paying attention to each other's work and starting to make connections between strategies. It was awesome to watch that kind of learning happen. I expect there are lots of resources about gallery walks and band shows and Math Congress. I know the ministry, the monographs, lots of them about those strategies. Good, Sandra, I'm glad you like it. It definitely worked well for me. When students are sharing, all the stuff we talked about earlier in terms of the trusting and respectful classroom has to happen. Absolutely true. And don't be afraid to go back to, these are the from the Grand Conversations in Primary Classrooms. This is from one of the language-based monographs, and this is about, Rich talks about a task, but I think if you just skim this over, when students are talking about their other math work, I agree with you, but I also think it's a great post these sentence starters so that students have the language to talk about each other's work without being attacking or negative or picky or any of those more negative things that students might default to because they don't have the proper words. Some other strategies I did for this consolidation was I would go around and I would circle part of the student's work in yellow. And whatever I circled in yellow was what I really wanted them to share. So whether it was just sharing in an inside-outside circle, or whether it was sharing in my Congress or in a gallery walk, that helped them focus on the math that I thought was most interesting or most unique or anything like that. Students became to really trust me that I wouldn't circle mistakes and I wouldn't circle ideas that would get them embarrassed in class, I guess. And so they were very willing to talk about their work. And I could almost always circle something on every sheet. It was really nice for me because I could really hone in on the learning goal. By what I circled, I could direct their sharing conversation towards my learning goal. And also before sharing, I give students time to talk to each other. So if we have to share what Mrs. Goindy just circled, what are we going to say? And they would practice back and forth to each other before they had to share to other students or to the whole class. Again, we all feel better if we know what we're going to say before we're just thrown in front of the spotlight, whatever that spotlight might be. Absolutely hard for the rich talk, Catherine, and I know that that's an issue. But maybe you could lead the conversation early in the year and just talk about, use their student work as your prop, and then you talk about it. And maybe that's bad advice. I have never taught French immersion. And again, so the next part in the consolidation, so probably 10 minutes of student sharing, and 10 minutes, I call it the highlighting. This is where we can use our teacher. We can draw out our learning goal. And this is when I explicitly say what the learning goal was for my lesson, what I came in. It might have been one of the process expectations, or it might have been one of the overall or one of the specific expectations, so one of the content-based expectations. But this is where I was very, very clear about what my learning goal was, what I was hoping students were developing skills towards. And I think there's another link going to come up to another document I gave related to the learning goal, but it is possible that I did not put it on that sheet, and if that's the case, I'll be sure to get it to you later. which I can see that I didn't. So I will absolutely put that up in a second. So 10 minutes for me, this is when I might annotate student work. This is when I might build an anchor chart. This is when I might co-construct that success criteria. And again, using the exact strategies that the students used. The last 10 minutes, always, always, always independent practice or guided practice. I used to always say it had to be independent practice, but I realized that if a student has shown during the action part and the consolidation that they're not close to it, I would pull a group of students together and do guided practice with me. It's this work that the students complete independent or guided that provides my information in terms of who should work together tomorrow in my partners. So I would never put my strongest with my weakest performing student on that day. I would never pair that way, but I might pair near neighbors. So maybe somebody that got it with somebody that almost got it. Or a student that demonstrated that they understand the math, but they need help representing. I might pair with a student that is great at representing ideas on paper, but is a little bit foggy on the actual math. All kinds of good ways to pair students, but it was never accidental. If I had independent practice on Monday, I knew who was working together Tuesday. Whatever was my criteria, it was definitely a very specific choice that I made. So that's basically what my three-part lesson was. And I would do that often. So a student who has problems, difficult explaining their thinking, I'd put them, and I knew they knew the math, I would put them with somebody that either could explain their thinking, or what I might do is pair all the students that had difficulty explaining their thinking with each other, so make maybe 3 groups of those students, and I would put them in a specific spot in my classroom. So I could patrol them working on the next day's action, and I could maybe have interventions easily by just walking up and down where they were working, so I could provide support more directly and more in time for when I knew they really needed it. A last big idea that I want to address, and I hope I have some time. 6 minutes. Okay, here we go. Joe had 4 apples. Sue gave him 3 more. Now how many apples does Joe have? This is kind of my world right now in kindergarten. So this is adding single-digit numbers. What do I do when this becomes too easy for students? So I provide many problems for students to add single-digit numbers. And when single-digit numbers become too easy, you might want to type your answer, you might just want to think in your head. I'm going to go on because of time. Quickly look these over and see if you see what's the same and what's different. This is a word problem, but it could be problem solving for students who have no idea that it's addition. So I haven't told them about adding. Right, so this whole, I think a lot of us, when single digits become too easy, we jump and go to double digits. But instead, what I would encourage us to do is go into these kinds of problem structures. This is from a ministry resource in the effective guides, and I have pulled out a brief PDF that exactly targets this, and I think I gave Louise the link to this in my speaker notes. I think that this is something that we could do to make our math instruction a lot stronger. Thanks, Louise. That's it.
What would you call that link? What would you call that document?
Types of problems is what I called it. Problem structures? Perfect. Problem structures, maybe.
Okay.
Because a lot of times we focus our math class on giving them results unknown. So 7 plus 4 equals blank. But I think we have to give them blank plus 4 equals 11 and 7 plus some number equals 11. What is the unknown number? And so if you're interested in this, read that. I didn't write this document. It's just a PDF that I pulled out of the larger ministry from the Effective Guides to Instruction, and that is the basic computation guide. I'm going to skip ahead, being very mindful of time. Memorization or automaticity. So does a student have to memorize the facts? I would argue no, because if a student has an automatic strategy, from the outside we would not recognize if they had just very quickly executed their strategy or if they had the fact memorized. So I would argue there's a difference there. These mental strategies are right out of the Effective Guides to Instruction. Again, the basic computation, I believe it's volume 5, and they're great to make sure that students have a range of these strategies. As somebody pointed out when we looked at the number sense, mental strategies were in many grades, many expectations. Thanks for that link. These are links, but will these links work, Louise? These are hot links. When they check the archive, will these links actually work, or will they just be underlined text?
I will make them workable links, absolutely. They won't be in the recording itself, but we'll put these links on the resource web page that you'll get a link for tomorrow, and that's where the archived recording will be, but all these resources will be there as separate links as well.
Awesome. Thank you, Louise. And these are on the same curriculum website that the Joe Bowler video was from. You could probably just find them yourself. The first one is a long webcast, which takes you through step by step, and there are many little links and many little tasks for you to complete if you wanted to do that professional learning there. And the other two are just Marion's small links. Marion's always good to watch. And because of that, this is what I wanted to end. My grandfather clock is chiming though, so I know that it's 9 o'clock, and I know that Louise and Syria have something else to probably add to this. And I'm sorry I kept everybody so long. So Louise, best if we just share this link and they watch it on their own?
I think what will probably work is I'm going to put the link in the chat, but we'll do our little wind up, and then folks, you'll be able to click on that link in the chat and it'll open, and you can go off and put your kids to bed and do whatever you need to do, and then you'll have that link to come back to. But of course it will be on the resource page as well for tomorrow, but it's terrific for Mary Kay to give you something to kind of go to bed thinking about. Right now I am going to just skip ahead to our feedback link. You know what? I'm going to leave that there for a few seconds so it gets captured in the recording. And then I'm going to get us here. And these links on the page are clickable, but I'm now going to hand it over to Syria.
Sorry everyone, I was having some technical problems clicking on the talk button. Thank you so much, Mary Kay, for providing us certainly with a safe environment for discussion and sharing so many effective strategies for solving problems in mathematics. Certainly great ideas shared here tonight. I would like to thank each of you for giving of your time to participate with us tonight. And again, for your thoughtful contributions. It was great to see your feedback both in the chat and on the whiteboard. I certainly do hope that you'll be able to make use of Mary Kay's suggestions, ideas, strategies in your classroom practice. I would appreciate it if you could take a few minutes and fill in the exit survey that Louise has there in orange in the center of the slide. This gives us, we need all the data that we can get to continue with programs like this. So if you found it effective and you'd like to see more of this, it'd be good to know from you. That way we can plan our winter-spring program. Do use the link that Louise has posted at the bottom left-hand corner there to look at upcoming sessions. We will have many other math sessions over the year. We do have more between now and December. So do check and also look for other sessions. We've got lots of technology sessions, and join us again. Share the link with your colleagues and invite them to join us in these exciting free, valuable PD. So thank you all again for participating tonight, and have a good night. I'd like to thank Louise specifically because she always makes every link work and everything work for us. So thank you, Louise, and thank you to everyone. Have a good night. And Mary Kay, thank you for, sick as you are, to be able to do the session tonight. Thank you all. Good night.